So let us solve the first problem through Jacobi method. In that case, I will open an Microsoft Excel sheet. Okay, so this is our Microsoft Excel sheet, and problem is written 2x plus y equal to 2 and x minus 2y equal to minus 2. So over here, let me begin with the number of iterations. So number of iterations, here I write x and value for y, and I reserve a column for error calculation. So I have to start, so I say starting point 0 and initial approximation for x, let's start for 0 0. So the starting point, just I highlight it. Okay, now the iteration would go 1 2, and these are the number of iterations. So how do we perform the first calculation? So x value, in Jacobi method, the x value is calculated from the previous value of y. Of course, we have, this is a two variable problem. So from first equation, I have already eliminated x. So x value can be computed as from first equation. So 2x plus y. So x would be equal to 2 minus y divided by 2. So here I write x equal to 2 minus the old value of y and divided by 2, and that's it. I got a value 1. Now y value, I will use the second equation, and second equation it simplifies y in terms of x. So x value, an old value of x can be used to calculate a new value of y. So this will be equal to, this is equal to x plus 2. So I have an old value of x at previous iteration, plus 2 and divided by 2, and this is it. And after computing the new value, we have to always compute error. So for example, I compute the error through distance formula, which is second order norm. So I can say square root of x new value minus x old value, it is at b3, and square of it plus new value of y minus old value of y, and square of it, and they are in the square root calculation. So right now the error is 1.414. Now I have to update the initial approximation and calculate the next one. In Microsoft Excel, I perform this calculation in repeated fashion like this, that I select the number of cells in which calculations are performed that needs to be repeated, and I select them, and then I make a left click and drag these calculations. They will be performed for many number of iterations. So if we look at the error, so we will find that the error is decreasing. We can perform some more calculations. So we have approached to the point where the error is on the order of 10 raised to the power minus 5. So that is the beauty of iterative method, that through very simple calculation, starting with some initial approximation, you can get to solution. So if you like, you can change the initial approximation and you can see the results. So that type of playing with this method, I leave that one for you. There is one important thing, that if you in the system of linear equations, it is always the choice of the analyst that how to order the equations. So I urge you to change the order, like eliminate x from the second equation and eliminate y from the first equation, and you will find interestingly that the error in that case will not convert. The error will not decrease, it would rather increase. So the that is something which is the character of matrix A. Like we said, that we require the positive definite matrix, or at least the diagonally dominant matrix. In this form of equation where we have eliminated x from first equation, if you look at the matrix A, it is 2 1 1 minus 2. So it is in this form, it is diagonally dominant. And also the similar thing is can be seen in the eigenvalue type stuff. So our next step is to generalize this strategy in for algorithm development, that we will look into the lecture stuff. So from this point, let's get back to our lecture stuff.